Hello my dear future doctors, welcome to Gyansrota. So today again we are going to start the PYQ session of the NEET chemistry, and question number is from 2018, and the first question number 46 is on your screen. So given van der Waals constant for NH3, H2, O2 and CO2 are respectively 4.17, 0.244, 1.36 and 3.59. Which one of the following gases is most easily liquefied? Now we are moving to the solution part. So if you see, they given the van der Waals constant. Okay, what are the values? 4.17, 0.24, 1.36 and 3.59. So this van der Waals constant is basically shown as letter A, and it tells about the intermolecular attractions. Now, if my value of A will increases, my intermolecular force of attraction is also increases. Now, if you see the solid, liquid and gas, the highest intermolecular interaction is found as in solid, then liquid, then gas. So, this is the order of intermolecular attraction. Now, in this we not require this solid part. So, I am going to rub this part and I am only showing this liquid and gas. Now, if you see the liquid having the higher intermolecular attraction, means they having the higher value of A. If they having a higher value of A, then this gas will be easily liquefied. So, if you see in the options, NH3 having the highest value, that is 4.17 of van der Waals constant, that is A. So, here the intermolecular attraction or interaction will be the more. So, this NH3 will be liquefied more easily. So, your option number 1 is the correct answer of question number 46. So, this question is taken from your chemistry 11th chapter from states of matter. Next, we are moving to the next chapter, that is 47. So, question number 47 is on the screen. Following solutions were prepared by mixing different volumes of NaOH and HCl of different concentration. So, in the screen you saw A, B, C and D, there are the different concentration they are given. So, pH of which one of them will be equal to 1. So, now we are moving to the solution part. So, if you see in this question number 47, we are going to use one formula, that is M1 V1 minus M2 V2 divided by V1 plus V2. Now, if you see here the first part, now this formula we are going to use it. Okay. So, now I am going to rub this formula and I am write it in here, M1 V1 minus M2 V2 divided by V1 plus V2. Now, for this A, if you see the M1 value is 1 by 10 and V1 is 60. So, 60 into 1 by 10 minus 40 into 1 by 10 and divided by 60 plus 40. For B, it will be 55 into 1 by 10 minus 45 into 1 by 10 divided by 55 plus 45. Now, for C, it is 75 into 1 by 5 minus 25 into 1 by 5 divided by 75 plus 25. Now, for this it is 100 into 1 by 10 minus 100 into 1 by 10 divided by 100 plus 100. Now, if you see the option number D, it will automatically come as 0 because these two terms are cancelled out. So, automatically 0. So, this pH should not be 1. So, we can neglect this D part. Now, if you see the other remaining part, here also the pH will not come as 1. Here also option number B, if you see it will not come as 1. So, if you see the option number C, if I am solving this part, so what will come? Here it will become as 15 and here it will be coming as 5. So, in above we have to got 10 by 100, and if I am solving this part, we are getting 1 by 10. 1 by 10 is nothing but 10 to the power minus 1. So, here the hydrogen ion concentration is coming as 10 to the power minus 1. So, now if I am using the pH of this part is coming as minus log of H plus. And what is the H plus value? Minus log of 10 to the power minus 1, and your pH will come as 1. So, your option number C is the correct answer of question number 47. So, question number 48 is on the screen. The solubility of barium sulphate in water is 2.42 into 10 to the power minus 3 gram per liter at 298 Kelvin. The value of its solubility product will be. So, this question is come from your equilibrium chapter, which is given on your class 11 chapters. Okay. Now, we are moving to the solution part. So, students, again these questions are very important, and this question is come from your KSP, which we are already solved with a similar kind of problem on 2019 question paper. So, if you see here it is given as 2.42 into 10 to the power minus 3 gram per liter. So, first of all we have to convert this one into mole. So, how we convert? 2.42 into 10 to the power minus 3 divided by the molecular weight of this barium sulphate, it is coming as 233 and it is coming as mole per liter. Now, if you solve this part, it is coming as 1.03 into 10 to the power minus 5 mole per liter. Okay. So, this is the concentration. So, if you see the barium sulphate is dissociate as, for space I am removing this part and I am writing here barium sulphate, and it is dissociate as barium 2 plus and SO4 2 minus. Now, how to write this KSP? KSP is equal to Ba 2 plus concentration and SO4 2 minus concentration. So, what is the concentration we are getting? We are getting 1.03 into 10 to the power minus 5 into 1.03 into 10 to the power minus 5. Now, if you see here 5 minus 5 and minus 5, it is coming as 10. So, leave this part, just focus on this 10 to the power minus 5 power and 10 to the power minus 5 power, something will come, and here 10 to the power minus 10 will come as mole per liter. So, if you see on your options, in that option, sorry, this is mole square, because here mole and mole, this is become mole square, and here again liter to the power minus 2. So, I am write it again. So, mole square liter to the power minus 2. So, how it will come? See, here the concentration terminology is mole per liter, this is also mole per liter. So, ultimately mole square into liter to the power minus 2. Okay. So, what is the answer if you see here 10 to the power minus 10, 10 to the power minus 14, 10 to the power minus 12 and 10 to the power. So, 10 to the power minus 10 is present only in one term, that is option number 1. So, option number 1 is the correct answer of your question number 48. So, now we are moving to the next question, that is question number 49. So, question number 49 is on the screen. On which of the following properties does the coagulation power of an ion depend? So, this question is come from the surface chemistry of your class 12 chapter. So, the coagulation power or coagulating power, this basically depends on both magnitude as well as charge. So, if you see the options, option number 1, the magnitude of the charge on the ion alone. So, this is not your correct answer. Both magnitude and size of the charge on the ion. So, see here magnitude also mentioned and charge is also mentioned. So, this is the correct option of this question number 49. See, it is very easy, only two things we have to remember, one is magnitude, another one is charge. Next, we are moving to the another question, that is question number 50. So, question number 50 is on the screen. Considering allogram diagram, which of the following metals can be used to reduce alumina? Now, we are moving to the solution part. So, this allogram diagram is already given on your theoretical part. So, allogram diagrams will help to predict the thermal reduction of your ore. So, you will get a graph like this. Here they are giving your delta G values, and for alumina you will get this, for other one you will get this kinds of graph, and this graph is already given your NCERT as well as in your theoretical part. So, if you see, this is nothing but this is your magnesium part and this is your alumina part, and delta G, if it is more negative, then that atom or that molecule will easily reduce the above molecules or above part in allogram diagram. So, if you see, the magnitude will having the more minus delta G value as compared with your alumina. Okay. So, in this the option number 2, because here the magnesium is given, it is the correct answer of question number 50, and this question or this allogram diagram part is given in your metallurgy part, in your NCERT from 12. So, question number 51 is on the screen. The correct order of atomic radius in group 13 element. Now, we are moving to the solution part. So, if you see, they ask you from group 13 as the atomic radius. So, what is group 13? So, the mnemonics again: बैंगन, आलू, गाजर, in thela. Okay. So, this is the easiest way to remember the group 13 elements. Okay. Again I am repeating here: बैंगन, आलू, gajar, in thela. So, if you go down the group, the atomic radius or atomic size is increases except your gallium, and gallium will come after boron. Now, what is the reason? Because gallium have a diffused d orbitals. which show poor shielding. Okay. So, what is the order should be? Your boron, then gallium, then aluminum, then your indium, and then remaining part. So, this is the atomic radius order. Okay. So, please be remember, because if you see here, it is not follow the general trend of periodicity due to the diffuse d orbital, and this diffuse d orbital having show the poor shielding effect. So, nuclear charge will be increases. So, nuclear charge is be increases, the atomic radius is automatically decreases. So, that is why gallium having a lower size or lower atomic radius than your aluminum. Now, if you see in your option number aluminum, here no, this is not possible. Now, here see gallium is smaller than your aluminum. So, might be this one. Now, here also it will be neglected, and here also see if you gallium is smaller than aluminum. Now, after that indium should become, but here tellurium is given. So, option number 2 is your wrong option. So, option number 4 is the correct answer of your question number 51. So, this question is basically come from your periodicity as well as the combination of your group 13 elements. Now, we are moving on to the next question, that is question number 52. So, question number 52 is on the screen. In the structure of ClF3, the number of lone pairs of electrons on the central atom chlorine is. So, now we are moving to the solution part. So, the ClF3, so how the structure, like ClF, fluorine, 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 and here 2 pairs of lone pair will be present. So, 3 sigma plus 2 lone pair means overall is 5. So, the geometry is sp3d, and what is the shape? Shape is T-shaped. So, what they ask? They ask you the lone pairs. Okay. So, how many lone pairs are there? 2 pairs of lone. So, if you see 1 no, 4 no, 2. So, this is the correct option of your question number 52. Now, we are moving to the next question, that is question number 53. So, question number 53 is on the screen. The correct order of n compounds in its decreasing order of oxidation state is. So, now we are moving to the solution part. So, if you see the nitrogen compounds and they ask you the decreasing, see this kinds of when they mentioning increasing or decreasing. So, please first mark it, and oxidation state. So, let us find out the oxidation state. How to find? So, here I am putting X, for hydrogen it is coming as +1 plus, and for this it is coming as 3 into -2 is equal to 0. So, for your understanding I am writing here HNO3. So, I am just changing this color. So, for nitrogen I am just mentioned as X, and for this hydrogen is coming as 1 plus, and for this 3, and for oxygen it is coming as -2, it is 0. So, X plus 1 minus 6 is equal to 0. So, X is equal to +5. So, +5 is the oxidation state for this nitrogen. Now, let us see for NO. N, N, O. So, again this one X for oxygen is coming as -2 is equal to 0. So, x is equal to plus 2. So, for this nitrogen is coming as plus 2. For N2, now for these kinds of molecules like N2, O2, the oxidation state is always be a 0. Now, let us see for ammonium chloride. NH4Cl. So, for nitrogen I am taking as x, for this one 4, and for chlorine it is -1 and is equal to 0. So, x plus 3 is equal to 0. So, x is equal to -3. So, the oxidation state of this is -3. Now, they are saying that decreasing order means who having the lowest, it will be go down. So, see here the -3. So, the oxidation state +5, +2, then 0 and then your -3. So, option number 1, if you see, this is the correct answer of your question number 53, and this question is coming from redox chapter of your class 11 NCERT. So, question number 54 is on the screen. So, which of the following statement is not true for halogens? Now, we are moving to the solution part. So, again I already mentioned, if they ask you yes, no, correct, incorrect, decreasing and increasing, first mark it, okay, not true. So, let us see all form of monobasic oxy acid. So, if they ask for halogens, so this is a correct option, okay. So, this is a true statement. Now, all are oxidizing agent, this is also a true statement. Chlorine has the highest electron gain enthalpy, this is also a true statement. Now, if you see the option number 2, all but fluorine show positive oxidation state. Now, in halogens they may show positive or negative oxidation state, okay. But in case of fluorine, they most of the time they show only negative oxidation state, except in one, that is your HOF, where fluorine oxidation state is positive, that is +1. So, this is not the true statement, okay. So, what they ask it, not true for halogens. So, this is not true for halogens. So, option number 2 is the correct answer of question number 54. Now, we are moving to the next question, that is question number 55. So, question number 55 is on your screen. So, which one of the following element is unable to form MF6 3- ion? So, options are given 1, 2, 3 and 4. So, now we are moving to the solution part. Okay. So, MF6-. So, if you see the boron, okay. So, this boron does not have vacant d orbitals. So, it is not possible for boron to form BF6 3-. So, this structures is not possible. So, your correct option is option number 2, which is the answer of your question number 55.